Okay, now we're going to look at the second part of problem set 2, and now we're going to consider whether or not we need a mask for bone conduction. In the first part, we considered whether or not we needed to mask for air conduction. So you'll remember from the unit that we need to mask for bone conduction whenever the unmasked bone conduction threshold shows more than a 10 decibel air-bone gap with the air conduction threshold of the ear under consideration. So let's look at right ear bone conduction threshold at 500 hertz. So we see the unmasked symbol for bone conduction is at 15 dBHL at 500 hertz. It obviously, from the positioning of the symbol, we can see that the bone vibrator was behind the right mastoid, but we still don't conclusively know that it was from the right side. So we look and see whether or not there is a significant air-bone gap between the unmasked threshold and the air conduction threshold of the right ear at 500 hertz, and those match up perfectly. So there is no need to mask the for right ear specific bone conduction thresholds. What about the left ear bone conduction threshold at 500 hertz? Again, you were encouraged in the problem set to ignore whether or not a masked symbol was there, but to instead determine if masking was needed. Well, again, the unmasked threshold is at 15 dBHL. Now, the air conduction threshold of the left ear is at 50 dBHL. So this is certainly a significant air-bone gap, and we're going to need to mask the right ear, busy the right ear, to obtain an ear-specific bone conduction threshold for the left side. And when we do this, in fact, we see that the threshold didn't shift at all, it didn't change, suggesting that at 500 hertz, the hearing loss is conductive. It's due to a problem in the outer and or the middle ear. So, yes, we needed masking for the left ear's bone conduction threshold at 500 hertz. No, we did not need masking for the right ear's bone conduction threshold at 500 hertz. What about 4,000 hertz for the right ear? So if we go to 4,000 hertz, we see that the unmasked threshold is at 50 dBHL. The air conduction threshold of the right ear is at 55 dBHL. Again, that's not a significant air-bone gap, only a 5 dBHL air-bone gap, so there won't be masking required for right ear bone conduction threshold. What about left ear bone conduction threshold? Again, the unmasked threshold is at 50. The air conduction threshold is at 60 dBHL. This, again, is not a significant air-bone gap. This is only a 10 dB HL air-bone gap, so masking is not needed. For some reason, masking was done, but it was not needed in this case. Part 2 asks you some specific questions about the audiogram. Which of these are true statements? The right ear has a better PTA than the left's. You remember pure tone average is the average thresholds at 500, 1 kilohertz, and 2 kilohertz. So in the right ear we have 15, 15, and 20 dBHL, roughly a PTA of about 17 dBHL. In the left ear the thresholds are at 50, at 30, and at 40, which would equal a 40 dBHL PTA. So yes, this would certainly be true. The right ear's thresholds, or excuse me, right ear does have a better PTA than the left. That's easily visualized just looking at the graph without any calculation. The left ear shows the greatest amount of loss for the mid-frequencies. Well, in fact, no, the mid-frequencies in the left ear show the best sensitivity. It shows these show the least amount of hearing loss relative to the lows and the highs, so that's not correct. The right ear has a high frequency sensory neural hearing loss. So if we look at the high frequencies of the right ear, again denoted by the circles, at 3,000 hertz, we have 45 dBHL threshold. We don't have a bone response there. So let's look at 4,000 hertz. The threshold is 55 dBHL. The BC threshold for the right ear is at 50 dBHL. Again, the BC threshold is elevated. There's no air-bone gap. That's the definition of a sensory neural hearing loss. So that's true. The right ear shows a mixed loss. Looking across frequencies, we've already said that the high frequencies show a sensory neural hearing loss. The mid and low frequencies show normal hearing. So no, the right ear does not show a mixed hearing loss. That's not true. The hearing loss is asymmetrical. Remember, asymmetrical hearing loss is defined as a difference of 15 dB between the ears at any two frequencies, or a 20 dB difference between the ears at any one frequency. You can certainly see visually how different the two ears are, especially for the low frequencies. So the threshold at 250 hertz in the right ear is 25, in the left ear that's 55. That's greater than a 20 dBHL difference at any one frequency. So yes, we would say the hearing loss is asymmetrical. So right ear has a better PTA, the right ear has a high frequency sensory neural hearing loss, and the hearing loss is asymmetrical.